Hey, welcome to week 4 in Python. We're going to cover pretty quick some stuff here. Shouldn't be too much, and then there will be an assignment. So first thing we're going to look at are data structures, just what's available within Python. So we've got, the first one here is a string, and it's just anything that's enclosed in a single quote or a double quote. There's no character types in Python. There's no single character, none of that stuff. So we've already seen this previously. Then, when we run the command for the user to input, when we just say input, they input regardless of what it is, whether they put in a number or not, it's a string. So then it'll have to be cast based on what you assume it is. So we've seen the string, the integers we've seen a little bit as well. Just any whole number, 5, 6, 100, -30, any whole number, integer, float. Any floating point decimal, also called a double sometimes. And that's just anything with a decimal, 1.1 or 1.0, 100.75132, whatever, something like that. Those are floats. A long is a really large integer. So based on how memory works in the system, integers are only allowed so many bits in memory. So if you need to go beyond that, you'll sometimes see that you'll enter a number and it's really big, say something like this. It'll have like an L at the end of it. The L just signifies that it's a long integer, and that's how it's being stored. A complex number has real and imaginary parts, so we'll never see that in here, but it's available if you ever want to use Python for some other course. A lot of other courses on campus are starting to use Python, especially the sciences. A Boolean is true, false, or none. None is the same as null if you're used to PHP or Java or some other languages, or nil if you're like a Ruby programmer. Sometimes it happens that integers can be represented as Booleans. This happens a lot in databases and things like that, where for whatever reason they don't have a Boolean, so they use 0 is false, 1 is true, and negative anything is nothing. Null, none, whatever. But true, false, and none are what Python has. And then there's one other type which is called a list, and it's actually three things. There's lists, there's dictionaries, there's tuples. So if you've ever heard of arrays or vectors or that, they are covered by these lists and dictionaries and tuples. And they're actually really powerful and really cool. So can't wait to get to those. It won't be this week. Probably next week we'll see a bit more on those. And it might be a little hard to understand at first, but we'll get there. So those are the data structures for numbers, words, lists that exist within Python. So string, integer, float, long, complex, Boolean, then list, dictionary, tuple. Okay, so I ran some stuff here, and I just want kind of show you the output of it as opposed to running through it again. So I've set a variable a, and it's equal to the string of hey. And strings, I just wanted to show you, are immutable, meaning that once you create a string in a, you can reassign a, the entire thing, but you can't reassign indexes of a. It's not a list, it's not an array, it's not any of that. Some languages allow you to say, okay, if I want to change this letter H now to an A, I can just reference position 0 on A, and this should become, as opposed to hey, it'll change. Well, what happened when I ran that is it says, okay, blah blah blah, string object does not support item assignment. Basically, it's immutable. Once it's created, it can never be changed. That's how strings work. Pretty much how most things work within Python, except when we get here, things get a little funky when it comes to that. When you mix it with functions and a couple other things that we will see, because lists are mutable, but everything else is immutable, meaning that you can't just reference some part of it and get something different. Okay, so say that you want to just print out, I just want to print this H. You actually can reference it. I'm I could just say that, print A at position 0, and it'll just give me the H. We can also use this kind of funky format of a colon and say from this to this, so kind of like from X to Y, it'll print. And if you don't provide one of them, it will just assume if it's the first one, say for example I don't provide the first one, well, I didn't print anything. Here's a better example. From whatever's first, print to the second character, not including. Here's 0, here's 1, 2 is the next one. Remember that all counting, starts at 0. So H is the 0, E is the 1, Y is the 2. So up to, but not including. You can do it the other way too. Start at 0 and go until you're done. So I printed the entire thing. If I reference something that doesn't exist, 32 for example, it says your index is out of range. Like I said, you can reference an individual position. Print A at position 2. That's Y. Just discuss that. So you can do ranges on things. You can do individual characters, so on and so forth. All right, next part here. So when you want to concatenate, when you want to have two strings or a string and an integer or whatever, you want to print them all out at once. There's a couple ways to do it. So here's just an example of the print function, right? Print hey sup. We can also do print hey comma sup. Okay, and it'll automatically, you notice there's no spaces, but when you hit a comma, commas include spaces, so it actually just goes ahead and throws that in there. So that's the same as printing hey sup. You'll see that the output's the same here. We can also use this. This is kind of the older method of going about it with these percentages, and so this %s that I've got written in here basically is a placeholder for a variable to come later, and the s signifies that it's a string. So this % in my print says, hey, this is a variable that's going to be replaced at when this is ran with a string, and then sup. And then I say, okay, here's my list of values that I want to be, replace things over here. So it's going to follow. I threw in a hey. So it printed hey sup. So that is that. It gets replaced. There's actually a list. I'll include it in the notes. A list of things, actually. It's here. So these are the types that are available. Like I said, S is a string, B is a binary, C is a character, D is a decimal integer, O is octal format, X is hex, N is a number, so on and so forth. There's some other things that you can do with it. If you're printing out, numbers or integers or stuff, you can, floating point positions. You can add zeros to it. Let's see. Before I go on to that, so this is, like I said, this is the old way to do it. This is the Python 2 method. It still works in Python 3, but Python 2 uses these percentages. Python 3 actually kind of changed it up. And so this is kind of the method that Python 3 uses, is to use this curly bracket, and then rather than the %, it uses the exclamation point, and then again the same things, s meaning replaces with a string, and then another curly bracket. So I don't really know why they did this, but this happens a lot in web templating. If you've ever seen like Handlebars or Mustache, the two templating engines, this is how they format, and they use this, these curly brackets, which are called handlebars or mustaches or curly brackets, to signify that there's going to be some variable, that this is a variable that's going to be replaced. So here, you say, okay, this is the variable, I got sup, and then you add this dot format. You're formatting this string and you're throwing in a hey, and it replaces it when it prints it. So here's some examples of that happening. You can do it by position, you can do it by type, you can do it by name if you're doing something like that. A lot of things that can be done with it. So here's one where it says rep R shows quotes, R str doesn't. And they use this S versus this R data type. Then they replace it simply with test1 and test2. And this is the output. Shows you that when they use the R, it put little single quotes around it. When they used the S, it didn't put quotes around it. You can specify a width of how much, how many spaces you want, something like that. There's kind of a lot of things that can be done with it. You can change, the separators when you're dealing with numbers. You used to have to put in 2 percentage signs using the old method if you wanted to get an actual percent sign. So, percent to get an actual percentage. So there's a lot of stuff that can be done with it. Not that interested in most of it until we really need it. But properly doing strings is a good thing. Okay, so a couple more things here. The data type true. This is a Boolean. This is a string. They are not the same thing. They do not equal one another. So don't forget that. Okay, so next thing here is dealing with strings. There's a bunch of methods that are built in. This is actually on the different page. I'll include the link for you. There's a bunch of methods that are by default available. You can capitalize, center, count, encode, ends with, find, blah, 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 blah. You can run a bunch of functions that they've written for you on strings that help you out with strings. For example, find. Maybe you want to find something within a string to see if it's there. If it is there, where's it at? You can run an index on it. You can count how many times something exists in a string. You can capitalize a string. You can. There should be a. Split the string, but I think there should be an uppercase version. There's a lowercase version. You can do a lot of stuff with strings built in by default that you don't really have to deal with. Okay, so you'll need these kind of things to complete the assignment in terms of dealing with print formatting a little bit. Nothing super complicated here. You'll need to use some methods that are given in terms of calculating. And then we're going to need one other thing, which this is kind of a new thing. So Python has a bunch of modules that are by default available. Like when you install Python, it installs them with it. But when you run your program, they're not included unless you specifically state to include them. That way programs can stay as small as possible. But then if you need to use them, there's 2 ways to include them in your code, and they're different, and there's a reason that they're different. So if we come on here, right, say I want to use some math stuff, so I go to M, okay, mathematical functions, okay, so there's a bunch of stuff in here, right, there's ceiling function, absolute value, factorial floor, let me think, there's power and log, trigonometric functions, angular conversion, so on and so forth. Pi is down there. I think it said, yeah, it's like a constant. So there's a bunch of stuff that's by default already available. And like I said, there's 2 ways to really use it. So the first one here is just by typing import and then math. So I'm actually going to go, let's see here. run a clear. All right, so if I come in here and I say, you know, hey, I want to use, okay, within math there's a square root function. Okay, return the square root of x. So if by default I haven't imported anything, if I run a square root on, say, 5, okay, it says there is no square root. So if I come in here and I say, okay, well, let's import math. All right, I got math. Math just got imported. Now let's, you know, if I want to run this square root on 5, okay, it still says there is no square root on 5. So when I say import math, it's imported the library, but I have to reference it in all of my calls in order to get it to work. Okay, so I referenced it by saying math, you know, on math, run this function. Okay, so that's fine. And it's really great if you have a bunch of libraries that you want to include. That way, you know, you don't have two of them with the same name that override one another. There's not another square root somewhere else doing something because this, by default, doesn't tell me where it comes from. So this is very ambiguous. I don't know which library I'm calling. If there were another, say, math2, right? If I import math2, there isn't one. But if there were and it had some different square root, then it would override it if I were being ambiguous about it. So this is a very unambiguous solution in that it allows you to always have to reference the module from which it came in the function call. There is another way to do it, and it's this other one, from math import, and you have to tell it what to import. I can give it an asterisk and it'll import everything in the module, and now I can run without referencing where it came from. So if I do that again, so again, by default, nothing, from math, import everything, give me that square root. There it is. I now don't have math defined because I didn't import math. I said from math, give me everything, just throw it in here, give me all the functions, but don't reference it. If I wanted to reference it, I'd have to import it. So hopefully that makes sense in how to import these libraries. If you just say import, then you have to reference where the functions are coming from. If you say from math import, you can literally list whatever functions you want to keep your imports really small, or you can say, hey, give me everything with this asterisk, and it will just give you all the functions that are there. But it'll then no longer, it'll make them ambiguous, more or less. So those are kind of the things that are necessary to help you out on this week's assignment. So if there's any questions with anything, shoot me an email. Thanks.